And it gives me great pleasure to get out of the way of the stage and introduce my good friend and working colleague, Jens Munnig. Jens is, as everyone knows, Jens. Who doesn't know Jens is part of this team? Jens, you need a new picture, by the way. All this wonderful health you've been doing. What's cooking in Snap is his topic. Jens has been such an anchor to this community, such an anchor, such a gentle, giving person who has supported all the feature requests and worked with them and worked with the team. He supported young students. He supported people learning how to program in Snap. He's made the code open source. It's such a delight to consider Jens my friend and consider Jens a working colleague. It's wonderful, wonderful. I cannot wait to see what's happening in Snap 8.0. And without further ado, let's give a hand for Jens. Woo!
Self and all right, some issues. So can you just again acknowledge that you're hearing me?
Yep.
Dan, okay,
Yep.
you can hear me?
That's
Okay,
great.
well, thank you so much. This is scary. We're here in tropical Heidelberg. There's basically all of Europe represented here. There is Ireland here. There is people from the Netherlands here, even from Austria. This is absolutely crazy. And of course, some Germans. So I'm here to talk about what's cooking in Snap. I was not going to give a keynote. Instead, I was just going to give a short demo. And so I've prepared a bunch of slides, but nothing else is working. So let me just try to share my screen and just show you some of the things. Share my desktop. So let me see. Can you all see my desktop? Yes, you can see it. Okay, so folks, what is cooking in Snap? Actually, Brian and I have incessantly worked on this for the past months and weeks, kind of in this very strange fashion where, you know, I stopped working when Brian started to work, and then we met at Brian's midnight my morning, and then we kind of had our meeting and we worked again. So what's been cooking? Well, Snap version 8 has cooked. Excuse me, yes? Yep. So, okay, yeah, black screen. Snap version 8 has cooked, and for the honor of the occasion, I kind of went to my wardrobe and got out, you know, an old piece of garment that I haven't worn for a long time, and I'm actually going to try to get this. Jesus Christ, this has been like over a decade since I've had to wear one. But since you're all here, I'm going to dress to the occasion and bind this tie because I've been thinking about funky things, how to introduce. Yeah, look at that. Wow. This is actually a white tie because as a former attorney, I was required to wear a white tie in court. And what this is about, it's Snap V8 is all about be more tie. Now, what does that mean? Okay, be more tie is basically a funky acronym too. Snap 8 lets you be more together, lets you be more interactive, and lets you be more expressive. That's kind of, you know, funky acronym. I was going to say SLOP. Again, I mean, several learners, one project. I thought tie was way cooler. It's just also way shorter. So I'm actually going to be done within the hour. And so these three themes, really, more together, more interactive, more expressive, has been what most of us have worked on during the past months where we were getting V8 ready. And so I just want to kind of jump right in and give you a bunch of demos what this actually means. So obviously, kind of the first one, being more together, this is all about modules. So in Snap 8, really, we kind of fixed some long-standing bugs, but we also introduced some new features. So it used to be that you used to be able to share sprites. You could export a sprite and import it into another project. You could also export a costume, you know, media and a sound and import that into another costume. And you could export libraries, but it already had some issues. So we thought, like, what are meaningful units of sharing things that will allow kids and all of you to work together. And so we wanted to have some larger granularity. That was scenes that we did last year. But this year we want to go more into the detail and also let you share individual scripts and even individual custom blocks. So I'm just going to show this to you right now. Oh, wait, I need to scroll this way. Can we see this? Yeah, we can see this. This is a little picture. This is Snap 8. So here's a project that Yadka knows well. We've been working on it. I think I might have shown it last year. So there's a bunch of custom blocks in here, which you can see when you say export blocks, a bunch of custom blocks that this relies on. So if I now right-click on this script, for example, I can make a script pick of this script, and I can export this script. And if I export this script, this is new. What I'm getting is, I'm getting this export in XML down here. And now I'm just going to open, oh wait, there's stuff floating around here that I can't get. Jesus, okay. I'm going to open it in another Snap. And so now if I get the receive message script in here and I just drop it in here, it's placed in my hand and I can place it anywhere in here. And if you look at that, this has a bunch of custom blocks inside. And you actually are getting all the exported blocks again that this script references. So you can now export libraries, scripts, blocks without getting any of these undefined blocks that kind of leave you in the lurch. And this is, we're hoping, makes it easier for kids to actually share stuff they're working on, including dependencies. Another big thing has been smart images. And smart images is something that we're really, really excited about. So this is actually, we got to give credit to who invented this. This was, anybody know Brian Silverman? Brian Silverman, the author of Turtle Art. Turtle Art has this cool thing that, you can make it to produce art, use blocks, but then the artwork itself, the file that is saved, which is, an image file, actually has all the code in it. And one day we were asking Brian, like, how do you did that? And we were imagining that he did some kind of, cool steganography using the least significant bits of the pixel data. And he told us, no, it's actually in the PNG spec. It has metadata, and you can just use it to save stuff in there. And luckily for me, there are some members in our community who are real programmers and actually know what they're doing. One of them is Darius Dorozalski. Is Darius here? Yay, Darius. Darius is one of those people who actually know computer science and know computing. And Darius figured it all out, how to read the spec and how to make it happen. And he collaborated with Jesus, one of Berkeley students, one of Dan's students from Berkeley, to make it happen. So I just basically took what they produced and integrated into Snap. So now we can do this. So let me just reload this project. It's an empty project again. So let's take another script. We're taking this when I am clicked script, and I can make a script pick. A script pick, folks, is really the stuff that you want to do, that you want to use when you document something. When you share documentation, you don't want to do a screenshot. You don't want to do a script pick. So if you do a script pick, what you get here is, a picture of the script. It's a ping. So let's again go to this other project and import this picture in here. And now, folks, what happens is there are several ways where you can drop this. You can drop this either anywhere where there's a scripting area, or you can drop it where there's not a scripting area. So what happens if you drop it onto the scripting area? It's a scripting pig. What happens is you get the script that is shown inside the picture, and you could just use it right away. And it also, of course, has all the dependency, everything it needs to run. This is what we call smart images. You can also, let me just import this again. If you drop it onto the stage or onto the corral, what you get is a costume. because you might actually want to do something to the costume. So now my sprite is wearing that costume and I might want to do funky things with it, right? But you can see if you go to the costumes tab, you see this little icon here? It shows you, it indicates you that this is actually does have a payload. So you can say, right click on it, get the blocks. And if you get the blocks, it again switches and you get the blocks from this ping. So basically what we did is we want to make every picture of every script that is shared, in BJC or in other online tutorials, or on the forum, to be shareable, that it also includes the code that it relies on. And see, since it includes the code, and since Snap can translate that code, it doesn't matter which language you export the pic from. You will see the picture in the language that you choose to export it. But if you export it in Spanish and some kid in Korea uses that Spanish pic, it will still get the code and will be able to switch to Korean to see in that. So this is the way how we really want to foster collaboration and sharing of things. And let me just show you one more thing. There are also tools for you who work on kind of more serious notes that, here's a little project that we've been using to do interesting stuff about the Titanic. So for example, here's a little, it's got some data of the Titanic inside. This is the passenger list of the Titanic. And this is something that see, happens to me. I need to enable JavaScript extensions. So this is a pie chart, for example, drawing the ratio of the survivors versus, the casualties. So it's, it's drawn on the stage, so we can get the pen trails from it. These are the pen trails. I can, add the pen trails to my costumes. So now I'm adding the pen trails to my costume. I click on this once, I switch to the costumes tabs. Here's the costume. So what I would like to do is I'm sharing this graph really that I've done. I want to include all the data that this was made from. So here is something that we have a new, like if you enable the extension blocks, this is where you get the extensions you can use to write, the blocks you can use to write extensions. There's something that lets you actually work with costumes. So you can embed data into a costume. So you want to get, the first item of my costumes now is this chart. I want to put this in here, and I want to put the Titanic data in there. Now it needs to be in a string format, so I need to first say, I want to get the CSV of the Titanic. This is now a string, so I can place this in here. And now if I click on this once, see what happens? I'm now having this costume, and it has a data tag in there. So now I can export this. I'm exporting this. It's called costume. Where is it? It's in my downloads. It's called costume. I can say this is Titanic age distribution. And so this is really just a picture. But if I now go to another tab, let me just reload this, make a new one, and get the Titanic picture in here, drop it in here. It doesn't have any blocks on it, so it's importing it as a costume, but you see data. And now if you right click on here, you can get the data. And what happens when you get the data is there's this new variable. It has the Titanic age distribution, and it's a string. And if you want to again have it, as a CSV, you can split it by CSV. And now you've shared sort of a result and the data that also lets your audience play with the data. So lots of possibilities for authors of extensions and of curriculum to share not just code, but sprites, projects, and all kinds of data. And the third thing is we wanted to make it easier to work on the large scope. Like last year, we introduced scenes, but the way that you switch it between scenes and share data among scenes has proven to be a little bit difficult. So we tried to make that easier by also letting you transmit data with every message. Let me just show this to you really quick. Let me just make a new project. So I'm gonna make a costume. I'm just gonna make the usual picture of myself. So here's a picture of myself. And what I now want to do is I want to switch to the next scene. So I'm going to make a new scene. Make a new scene. This is a new scene, now scene 2. And when something happens in the scene, like I want to say, you know, when I receive, I'm making a new message. I'm saying when I receive show, I want to display something. I want to display some data that I'm getting. So I want to switch to a costume. And I actually want to send this costume. So I can now expand the slot, not just when it's anything, but I can send data with it. So all the data that I'm getting, I want to show as costume. So now I'm going back to my first scene. And so I want to switch to the next scene, and I can click on here and send some data. Now what I want to send is actually my current costume. So here's my costume. Here's my costume. And when I try to send this, I'm going to get an error because it requires me to send just data that can be put into a CSV or to JSON. So what I'm going to say is I'm just going to send the pixels of my costume. This is now a table, and I'm switching this along, and I'm sending the message show with the data pixels. So now what happens is I click on this, it's getting the data and it is rendering it as pixels. So I'm actually making a new copy of this. So this is kind of cool because it lets you build your own protocols. So of course, if I draw another thing like my usual example, I'm drawing a heart and I'm filling this. So now I have a heart here, but if I switch to the next scene and it gets the heart, see what happens is, yeah, it gets all the data, but there's some data missing. It tries to render it, but it doesn't know the dimensions of the costume. So what we can do is we can make another data structure here where we say, okay, let me just send a list whose first item is the costume, the pixel, the second item is the width, and the third item is the height. And now, when I go back to here, I can't just switch to the costume, but I need to kind of make a new costume. So I'm making a new costume. I could say, you know, make a new costume, item 1 of data, item 2 of data. We can make this easier. We could just say, make a new costume. We're just going to call this as a function. Call the new costume function with the input list here. So I'm going to try this. So now I'm also getting the sprite here. And let's try just one more time so you really believe me that it's working. I'm going to draw, yeah, something like this. Okay, so now I've got this clef. That's actually, yeah, totally works. So this, by the way, doesn't just work with scenes. It works with any broadcast. So you can now send and transmit data along with a symbol. You don't have to watch out for any message and then parse whether that message itself is a data structure. You can send a symbol, send a message, and include data with it. So it makes it much easier to kind of produce these kinds of protocols that you want for complex games and multi-level projects. Okay, next thing is, so this was the togetherness, the modularity. The next thing is menus. We wanted to make Snap more interactive, and it's kind of in retrospect, we were wondering, like, how did we take so long? So usually what you see is tons of projects where, you know, you're asking something, do you want to go to level 1? Press 1. Do you want to go to level 2? Press enter 2. And you use the ask block for this. But we thought, what, like, you know, so we can ask your name. And then when I say Jens, I can show the answer. But what happens if I say, okay, what if you know, the name is Ryan, Yadka, Michael, or Lauren? I know there's just going to be 4 names. So what if I'm asking for a list? Now, if I'm asking for a list, what happens is we're popping up a menu. And in this menu, you can select a name, and I can select Yatka, and then the answer is Yatka. And it's kind of, this really gets rid of all the things where you need to ask something and then kind of go through all the possibilities with the uppercase and lowercase. And so we made these menus really such that even if you resize them, they resize along. And there's kind of a funny semantic there. You can build very complex menus. You can put everything into a menu that is first class in Snap, including costumes, sprites, lists, and things. And there is a whole library that does that. Oh, actually, let me show you this library. So if you go to the libraries, there now is a menus library, and watch what Michael did. You can now see exactly kind of which custom categories and which blocks are in the library. So if you import the menu library, you get a bunch of new blocks in sensing. And there's one that says menu examples. And you can use this. You can basically use these blocks and use the menu examples. You edit it, you're finding a bunch. You can say, you know, what's your name? You can prompt, choose something, and you can do this. You can also do sub menus and selectors and stuff like that, and also kind of, you know, show something else in the menu than what is being reported. Like you want to say, you know, select north, and it'll be, you know, 0, and south will be 180 or something like that. So plenty of things to do. We even made it so that you can use it to interact with speech balloons. So you can have little kind of chat histories. If you might want to play back an interesting conversation you had with an AI, and you want to kind of start again at some point where the conversation maybe turned a little strange, and say, okay, up to here it was okay. So you can say, okay, this is where I want to resume the conversation. So more interactive menus. Let the user make a choice from a list of options. We can use it if you don't have any options. You can just also pop open kind of, you know, a notification or a warning, and it also lets you interact with chat protocols. The second, that was kind of the I and the tie, and now we're coming to the kind of last big feature we added, and that is power blocks. And you know, we get this asked a lot, like, how is Snap different from, you know, Scratch or App Inventor? And I have to come up with a different answer every time I'm giving a talk. So here's my answer I'm giving you this time. And you know, maybe next time I'm going to give you something else. So language-wise, you know, all those other languages have blocks, duh. But Snap has power blocks, get this. So what's a power block? A power block fulfills our vision of no ceiling. Okay, hey, I'm really proud of this. What do you get when there's no ceiling? You get air. Ah, got it. It's another acronym. So what does air stand for? Okay, I'm stretching this a bit, I guess. So air. So we have these blocks, you know, that have arrows in Snap, variadic blocks. You don't find them anywhere else. We have blocks that extend the domain of input slots to also take lists, and our with input list block callback is a special form of that. And we have blocks that have rings on them. So that's where air comes from. And we call these, variadic blocks, hyper blocks. And I'm now calling the blocks that have rings on them Metablocks because we added some. And over the past year, we've really extended all three of these domains. What you're seeing here already is something that is already online. We published it in a minor release before. So we now have more variadic blocks. For example, like we have the plus block, and it's not just 3 plus 4, but we can extend it and also say, with as many slots as we want. And those are the kind of associative infix reporters. We can also use it, on the numbers from, if you drag the numbers here onto the variadic input itself, it doesn't turn red. That's what people think. It turns the color of a list. So if you drop it here, the plus block turns into the sum block, and you immediately get the aggregation of a list. And there are a bunch of other blocks, like the minimum and maximum blocks and the multiplication blocks. So power blocks part 1 are variadic blocks that have been extended. The second is hyperblocks. We hyperized, we extended the domain of some other function, some other functions that we have in Snap, most notably of some of the special forms. So let me just give you one example, and one that I'm particularly proud of. Let me again make a picture of myself. Ha ha ha. Never gets old. So usually what we show is kind of when you get the pixels of the current costume. Actually, I'm just going to say the camera. We're getting this giant table, and now we can do kind of operations on this. But what if the operation that we want to do on it requires a conditional, like an if or else? And that's when we usually kind of need a loop or some map. There are some special cases where we can now use this directly in the if reporter. For example, we could say, if those pixels are greater than, let's say 80, I want to make them 255. Otherwise, I want to make it into 0. So I can do this very quickly. So now most of it turns into 255. Actually, I don't know. Let's just look at this. So I'm going to switch to this costume. And what I'm getting is sort of an aha effect of, kind of Andy Warhol effect. And the cool thing is, I can do this now, since it's very fast. I can do this now also, and the usual trick is, I take the video snap on the stage instead of the camera. And I want to do this all the time. And now I basically have a camera that does this in real time. And I can go even further. And that's kind of the cool thing about using if this way. I can also use a threshold like that. So I could say, what's the distance to the mouse pointer? And say, the distance to the mouse pointer is here, where the threshold is the 80. So now as I'm moving, and as I'm moving the mouse, I can sort of increase or decrease the threshold. And I kind of get this funky thing that basically computes my live video down to just 8 colors using hyperblocks. So we hyperized a bunch of other blocks also, like the AND block and the OR block. Have fun with that. And the last thing that we added was Metablocks, more Metablocks. Now, what are Metablocks? Metablocks are blocks that access blocks, and you used to see them. We're using, map and keep, combine. We're also using loops that have C-shaped slots, which are just a special case of rings. And so we use them for control structures and for halves, for higher order functions. But we also, since last year, use them to access the internals of blocks, like the definition of a block or the label of a block. And now in Snap 8, we can also change blocks and even make blocks that make blocks. Let me show this just very quickly to you. So making a new project. So let me actually just very quickly make a block. It's going to be the block foo. So here's my block foo. I'm not going to put anything in here. Here's the block. And in the control category now at the very bottom, there is a bunch of new blocks. And I'm going to, you already know the definition of block. That used to be in sensing. Now it is in control. The definition of an empty block is empty. But there are more choices. You can get the label of a block. You can get the label of the block as foo. You can get the label of any block, the label of the if block here. You can already see there's something there. You see there's an if, and then there's two underscores. So input slots are represented by this as underscores. You can also get other stuff, like you can get the category. The category here is a number that's just 1, 2, 3, 4, 5, 6, and the category of the if block, for example, is 5. What else can you get? You can get the find out whether it's global or custom. You can find the type. That's whether it's a reporter. You can get the slots. These are also kind of the slot types. So slots kind of have numbers. You can look it all up in the manual where it's all documented. But the new thing is that you cannot just ask these blocks. You can also change them. So we can set the label of foo to be bar. And now look what happens. It actually changes the block in place. We now have self-modifying scripts. And just before, it's kind of scary. You can set the label to actually, let me try this. Oh, kids, don't do this at home. So this is the label of the block. Gosh, I can't believe I'm showing this to you. Okay, good. I'm joining the label of the block. Actually, I'm going to rename it again to foo because that's funnier. Oh, look, I changed it both. So I'm going to join it like this. Ooh, look at that. Oh my God, what is going to happen now? I'm just going to make this 100 times. Is this actually going to work? Okay, Jesus. Whoa, look at that. We've got self-changing scripts. So this is kind of a nerdy thing to do. But we can also actually do meaningful things with it. We can change, we can set the category to another number. So we change its color. We can do the same thing, we can say, for I equals 1 to 10, set the category. Actually, it's going to run so fast that I'm going to have to make it slower, 0.4. And you can see it's cycling through all the colors. So we can now, okay, so now you can kind of knock yourselves out with making kind of, programmatically changing the way your scripts look. But told you, we also now have blocks that make blocks. And that's kind of cool because there are several new things that it lets us do. One thing is kind of pedagogically, sometimes kids, sometimes teachers like to actually see the block definitions without them being hidden in the block editor. We can now do that. But we can also do way other cool stuff. And I urge you all to come to Brian's session, who's going to go into way more of this. So let me just show you how this could work. So I can now, define a block, and I could say, I'm going to define the block jump. And I'm going to say jump is going to have an input. So I'm adding this underscore. So since it has an input, this is where I put the definition. I want to put a formal parameter here. And now I can say Okay, let's define the jump block. So I can say repeat 10, change y by 10, and let's just duplicate this. Repeat 10, change y by, oh, actually it's not 10, it's repeat steps, right? Yeah, look at that. So now I've sort of defined it. I just want to make sure to also set the color. So now I can set the, the category to the motion category. And I can set the shape of the input slot. I don't have to do it, but I can set the shape of the input slot. If it's just one, it'll take you can just type it in here. Otherwise, you need to type in a list of things. 0 is just a regular thing, and 1 is numeric. And I drag the block in here. So I'm changing the thing for every block. So now I'm going to go to the category and click on this. And I've actually just made myself a new block. Let's try this. I can take this and let's just use it for 10. And it's working. And if I open it, I can see the definition in there that it created for me. So this is how we can now also make custom blocks. And if I want to change it, like I want to, add another word, I want to say steps high. It now also kind of makes a new block because now it has a kind of a new spec, a new way, and then it creates a new block. And so there's also a block that lets you delete again blocks that you no longer need. So look at that. I can't believe I'm showing this to you. So I'm taking the delete block. Oh gosh, kids, this is so crazy. Look at what happens. It actually deletes the block. It's magic. It deletes the block that's in the magic circle. Okay, so far so good. This was all great, and I thought I was done. Then Brian said, but Jens, recursion. What do we do about recursion? You can't live with recursion. That's the big R. So, okay, God, let's do recursion. What do we do with recursion? I'm going to make a new block. And so I'm going to define the usual thing. I'm going to define a block that is the, underscore exclamation. And that is the factorial. That's taken n as an input. And so I'm doing the usual, if n is 1, then return 1. Otherwise, say, this is n error, and now I've got a chicken and egg problem because I don't have the block yet. I can't drag it in. And so the idea that we came up with is that, well, we have this variable and it represents the block. So we call it. That seems kind of straightforward. So we call the block with the input n-1. So let's actually try this. Also notice that I'm just putting in here a reporter. I don't have to put in here a report block. If I'm just putting in a reporter, what's going to happen is I'm just going to click on this. So now I didn't specify a category. So here's my factorial block. I'm going to put in 5. It's getting me 120. So it works. Let's look inside of what happens. So inside, you notice that it auto-generated the report block for you, but you're also seeing that it doesn't quite look the same on the inside as I defined it. Here I'm putting in a variable that references the block, but in the definition, the way definitions are in Snap right now, they don't have an environment, like it wouldn't know what block stands for. So we have this new special block that is this script, and this script is a special form that refers to the nearest ring, the nearest function scope that this is in. So you'll also find this in here. So if I click on this script, I'm getting this script. If I'm getting a list of, this script and this script, look at this. This is kind of fun. Did you think of that? So there's kind of fun stuff you can do with this script. You can basically capture the current environment that this is running at. So what we're doing here is we're doing a subtle compilation of blocks into blocks to make this happen. There are some more subtleties that you'll find when you play with this. For example, I can just encourage you to read the brand new manual that Brian has worked on all through last night. There's a fun little example in there that is even more mind-blowing, where Brian shows you how we can make the blockify block, a block that takes data and generates a new block that makes that data. And you'll see some more subtleties with this script thing. So Metablocks, what is really our motivation? The motivation is partially to do stuff like this, but it is also to do some other things. Like we've been discussing this also with Eckhard Modrow from Göttingen, who has done a lot of teaching and has a lot of experience in Lower Saxony of students doing the Abitur. And there are a bunch of exam questions where students have to make abstract data types. And so what they give them is, a name and a list of fields. And basically they have to write all the accessors. They have to make a new generator that generates a new instance of that data type, and then all the accessors of the different fields. And you think about this, this is really something that we can now automate. So let me show you how to. Here's a little script that is kind of the least viable form of an abstract data type. So we're just defining a constructor. You give it a name and a bunch of fields. We make a constructor, and for every field we make a setter and a getter. And you know what? This is a script pig, so you can see where this is going to. Okay, so I'm just going to import this into Snap, so now since this was a custom block, here is the custom block. Here it is. Let me just open this so you can see this. This was all inside the costume that I implemented. So now I can make, actually, I'm going to leave this open. I can make an abstract data type of, for example, person, and I can say this should be, a name. I can extend this. I can say, okay, this is a first name. This should have an age, a person, and maybe an address. You get the idea. And so now what this does is when I click on this, it generates blocks that operate on this data structure. So here's this new person is actually this. It returns just a list with a new person. So if I make a new person that is named Brian, oh wait, no, I have to say Harvey. Brian, actually, let's not some age. Let's be very private. Okay. Basically, what I'm getting is just a string, but now I'm also having all the other accessors. So I can say first name of this person is Brian, and this is all auto-generated. I can make another ADT with other fields and thereby just add these blocks. So expect this feature to be used in future libraries that we do, where we need to generate things on the fly. Do you have to learn it? No, you don't. But it's a cool feature that library builders and advanced programmers are going to totally exploit for future references. So this is about Metablocks. And there's so much more in version 8. I've just barely scratched the surface. For example, Brian has worked with Megan, and Megan has drawn these wonderful costumes that are now in the costumes library from her webcomic. And so check him out. There's all kinds of poses and postures. There's more extensions. SciSnap from Eckhard Modrow has a whole new version giving you mind-blowing capabilities of graphing data, of machine learning, of doing all kinds of stuff that boggle my mind. There's the MQTT library from Simon and Xavier, and there's a brand new, super awesome TuneScope library that probably all of you who've just been to Glenn's and Joe's workshop have used. many things. As usual, this isn't just Brian and me. This is many folks have really worked hard and contributed to this. Michael has really worked on the libraries again and on the kind of library preview thing and on the design. Yatka has worked on curriculum stuff. Bernat has contributed, and there's Jesus and the Berkeley students working on autograders. Oh, by the way, autograders is also where we need these meta stuff for, so we can read these things. Many folks have contributed. Darius, many people from the community. So this is really kind of not just the tie that I'm wearing for all the audience, but for collaborators. This is to honor all of you. It's been a pleasure. It's been so great to work with you on this together. Yay to Snap V8. Enjoy it.
Woo! Thank you so much, Jens. Thank you so much. I'm looking to what I cannot wait to try all these features out. This is just an amazing suite to tie it all together and to connect it. The potential is unbelievable. This Snap 8 goes as far as to go even farther than Snap 7, which blows my mind because Snap 7 did all these things that I would never have imagined. What an exciting update. This is so delightful. I'm looking at my Snap collaborators. Do we have time for questions, or should we kind of go into the break to go back to being on time? What should we think? We're 5 minutes over. Michael says 2 or 3 questions. All right. I'll try to field them if someone wants to raise their hand or just speak out. We're kind of casual here. What questions do we have? And this was released yesterday, is that right, Jens? Feel free to ask any questions. I'm looking at the chat.
All right, I've got a question. So not every recursion is always to the most immediate scope. So is it limited to only recurring to the most immediate function like that?
We can't hear you, Jens.
Can you?
No.
You muted yourself. Oh, I have to. No. You have to go through this, right? Can you hear me now?
Yep.
Okay, great. Okay, Ken, I was not showing you the more complicated example because of time constraints, but there is one in the new manual. Check the chapter on meta programming. There is the example of the Blockify block, which captures an outer scope. And basically, we do this by doing some compilation where we know that there's an outer scope, so we capture it and then we reference it from the inner scope. So yes, you can have stacked scopes. And by the way, this was Brian who, of course, immediately knew this. So when I thought I was done when I had this, script, this script reporter, and I thought, yeah, wow, I could do recursion. This is great. Everyone said, oh, what if we have indirect recursion? And then we figured out kind of how to work around this.
All right, another question?
Yuke has a question here. Okay.
Where should I talk?
Yeah.
Here?
Just go ahead.
Well, my question is, the great people of the MIT, they built Scratch 15 years ago right now. And thanks to them, we have Snap. Because they didn't want to make it too complicated for kids. And Ryan wanted some extra stuff to do computer science with Scratch-like things. So you introduced extra features. I think that was great, and you're still doing great, and I'm totally blown away with what you showed today. But where will you stop?
Great question. Great question, you. Where are we going to stop? And you know what? We can laugh about it, but I've been asking myself this. In a way, for me, this is kind of moving maybe one step beyond my own comfort zone. Right. So, you know, now we have these scripts that can self-modify. Like, is there any, like now we're even taking the certainty out of, because we also, you know, out of what things mean, because they can change their meaning. You can overload blocks. We've even, like what I didn't show yet, but read it up in the manual. There's another chapter on macros, on list-style macros, which we now have. So we can now also run a block in the scope of another block. And so this is, of course, something that you can do all this kind of really hackery. You can actually inject code into another closure to actually modify it. But you know, it's been one of our guiding principles. And of course, Brian has formulated in his way that, you know, we're not here to teach about how to do things such that a big company with, you know, I don't know what Brian says, you know, 500 mediocre programmers doesn't run into issues of them stepping on each other's toes, but we're here to empower learners to do things. And I was pretty blown away when Brian referenced me to the chapters in his book, Computer Science Logo Style, that actually has a bunch of really, really awesome, very hands-on and very concrete examples that use these features that are really just plain fun. So where do we stop? Brian and I have discussed this. I think we're pretty much done feature-wise, but there's, you know, there's always stuff to keep up with. And you're right that, you know, Scratch wasn't written to support computer science. And maybe that's part of the problem. We're having all these discussions about, you know, where people say, oh, but we have to use Scratch. And then others say, but it's the worst thing that happens because it doesn't support it. I've never heard Mitch or Karen claim that Scratch is the right tool for teaching computer science. It's what everybody else has made out of it. So for them, it's about, you know, computational fluency. It's about sharing. And for that, it's great. So yeah, of course you can use it as a ramp up, but if you want to, you know, teach computer science, use Snap because there's so much more.
Wonderful. Well, let's thank Jens again for his wonderful keynote. Woo! Outstanding.